Hopefully, the presentation you are currently observing. Actually, there is a relation between in-depth exploration of groundwater and surface water extraction. So, we all know that is the surface water mainly combined with river, pond, etc. And whereas the groundwater, we know the percolated water from soil to ground. So, there is a linear relation between surface water and groundwater in some cases of geomorphological aspects or climatological issue. So in that particular scenario, we tried to discuss about the software or handling system that we observe in case of a groundwater surface water interaction part. We all know the hydrological cycle or hydrological system, that is the interconnected surface water and groundwater mixing nature because of the surface to subsurface flow, and these subsurface flow are formulated towards the salty and brackish water zone, then it also evaporates. This completely hydrological cycle, we all know about it. And so the interaction, the importance is very critical role in case of a certain ecosystem or certain development. So actually, no kind of methodology tried to develop in that particular area for surface water and groundwater study and their relation between some experiencing part. So this is the total hydrological system. In that particular hydrological system, we know the cyclic movement of water from precipitation to surface, then it's moved as a percolated groundwater, and also it evaporates towards the cloud formation and the total cycle begins. But in case of some nature of soil, we also know that the porous kind of soil where the surface water moves, sometimes the water percolates and deposited in aquifer. As we all know, that is the storage of groundwater. In some portion, this kind of storage is also happen. Mainly, this kind of storage is mainly happen because of some particular kind of soil where the porous medium is higher, and due to this porous medium, the water easily percolates towards the underground and formed as a groundwater or aquifer formations. In case of a hydrological cycle, we all know its definition, that is the explanation of the continuous movement of water between the atmosphere, land surface, and subsurface. This is the whole circulation procedure of groundwater. We all know after precipitation, infiltration happens in aquiferous region, and this the groundwater flow. Sometimes this groundwater flow open up towards the ocean, sometimes in river. Like in India, there is very example. We also know the karst topography, another part of criteria where the groundwater move towards the surface section. The main part of hydrological cycle is evaporation, precipitation, infiltration, runoff, and transmission. We all know these kinds of feature. And in case of a groundwater surface water connection, that is the groundwater and surface water very integral components of this cycle, influencing each other dynamically. Because there is a dynamic relation is built upon this groundwater and surface water particularly. Whereas when the surface water moves over the ground and surface water moves over the ground and percolated in groundwater, and sometimes it's open up to ocean that I previously told you. And there is a relation is also happen between them. Sometimes the surface water values are also added towards the groundwater in some condition according to some geomorphological or some climatological aspects. So this kind of hydrological cycle I previously explained, and all the geomorphic transformation from precipitation to transpirations and finally stream and ocean and evaporates, all it's happened in a particular hydrological cycle. In particular groundwater dynamics, we also know the formation of aquifer from the background of geography or any other geological aspects. We also know the formation of groundwater, that is the aquifer and subsurface porous media, basically. So in case of a exploration of the geological process, that is that also leads to the formation of aquifer. And classification of aquifer is mainly happens on basis of permeability, porosity, and geological characteristics. And the groundwater flow mechanics mainly depend on groundwater flow, including hydraulic gradient, aquifer properties, regional and geological structure. In case of a geological or geomorphological students, we also know the particular hydraulic gradient in porous media, in aquifer media, and their aquifer properties, and their regional geological structure. The regional geological structure varies from region to region. Mainly the interaction between groundwater and surface water mainly happens in case of any porous media like karst topography or others. These are the part of groundwater dynamics, actually the formation of subsurface flow, the recharge, the evapotranspiration is all happen in different climatic media in different manner and different scale and different rate, especially in snow region to forest and to oasis and desert region. The oasis region is mainly used for the used for recharge and evapotranspirations method in this criteria. After that, the period is cyclically move between these 5 periods, mainly cyclically move in case of a particular groundwater dynamics. Firstly, we know the surface flow, then the surface flow is become penetrated as a groundwater, then the drainage happen, whereas in case of irrigation purposes, we know the evapotranspiration in irrigation purposes, the groundwater table are quite uplifted, and then it downlifted due to the huge amount of withdrawal of water mainly happens in urban area or later part is also analyzed. So in case of a surface water dynamics, the river system are also depend over the channel characteristics and flow patterns, discussions on factors, river flow such as gradient, discharge, and sediment transport. And in that particular criteria, so in case of a surface water dynamics, we all know the river system and lakes and reservoir system, whereas in case of a river system, it's depend over the river morphology, channel characteristics. This is at the surface water system. Whereas in case of a surface water system, the river flow influencing various kind of river flow, such as gradient, discharge, sediment transport, is mainly happen all over the part that is necessary for surface water system or river system particularly. In case of a lake and reservoir, they are also integral part of surface water system. The hydrodynamics of lake and reservoir, including water balance and interactions with groundwater. This mainly happens in case of a particular media, particular storage media, or rather part. Generally, the water balance is mainly depend over the lakes and reservoir, and in that particular lakes and reservoir, we all know the sometimes the water penetrates and sometimes it also evaporates from that upper media, basically. So. So in that portion, we also know the surface water part, that is the river system and lakes and reservoir. They are also integrated with each other in case of a groundwater. And the cyclic movement happen from river system to groundwater in that particular nature. So these are the surface water dynamics. Previously, I showed you the current groundwater dynamics, and these are the mainly the surface water dynamics. These surface water dynamics is different. Surface water dynamics is mainly associates with the interaction with groundwater. That is from in case of a particular geomorphological sites, from mountain to ocean, there is a chain of surface water dynamics we also provided, we also show here, and the human intervention, that is the damming, mining, aquaculture, is totally depend over this surface water dynamics. In case of particular criteria, sometime the surface water penetrates or percolates. We all know that from rainwater after surface runoff, water percolates and storage as a groundwater. And this groundwater also withdrawal for agriculture, for manuring, for water diversion, and also for urbanization and industrial use. So due to the development of industrialization and urbanization and also the healthy nature of civilization, there is a chain system between the surface water and groundwater always happen, always perished due to because this balance is also uncertain in some places where the urbanization and population growing larger. But in places of rural urban fringe or others area, the groundwater and the surface water balance there is a equal balance also happens there. So the interaction mechanism mainly depend on recharge and discharge process. We all know that recharge process, basically recharge after infiltration of water from surface water, mainly recharge is happen from surface water. And discharge mainly done over the surface water. That is the discharge of stream water, we also know that. And recharge happen from the soil porous quality. And main influencing factor are hydraulic conductivity, geological formation, and climatic condition. Hydraulic conductivity is basically mainly overlying and differ in climate to climate, whereas the geological formation also differ from various geomorphic feature and climatic condition also varied. And this kind of feature mainly affected in oasis region, especially in arid region or semi-arid region, the fluctuation must be higher there. So these are the interaction mechanism between surface water and groundwater. Suppose there is a surface water body and this is the river, and due to the soil quality, sometimes the recharge water and moves towards the surface median. Basically from this surface media there is a recharge, there is a irrigational well or artesian well also happened, and this artesian well also uh, excavate larger amount of groundwater. But sometimes, in case of a summer condition, when river water recedes, sometimes the groundwater percolates towards the river, and groundwater also fulfill the river water quality. It happens in some climatic region in our West Bengal. This kind of variation is found mainly North Dinajpur, upper North Dinajpur section. The main river of this part are generated to the higher excavation of groundwater table. Mainly the groundwater table fluctuated over the surface water and they form some small type of river in the Islampur, Chopra block or in Uttar Dinajpur section. So what is Haycrass? So Haycrass is mainly used for different criteria. We can use it as a surface water. We can use it as a surface water interaction. We can use it as a surface water penetration purpose. Haycrass is mainly used because to overview the surface water, overview the scenario of surface water, overview the river, actually the one-dimensional flow. Another part is one-dimensional, two-dimensional flow, that is the lateral movement of water flow. And sometimes it is also characterized with different kind of feature, different kind of feature also. So in that particular case, HECRAS is mainly used for explanation of hydrology engineering sectors river analysis system. USA developed it, US Army section is mainly developed it, and it also have some graphical user interface and key functionality. This graphical user interface, this is the medium where GIS is incorporated in HECRAS. And mainly we use HECRAS applications over river channel design, floodplain mapping, bridge hydraulics, and also groundwater hydraulics and water quality scenario. So HECRAS is mainly developed by the US Army and it's mainly a freely downloadable software. This kind of freely downloadable version we generally used in various criteria over river modeling, over sometimes the groundwater modeling, over sometimes we also use the flood modeling, etc. So this is the main features of HECRAS. Mainly, previously I analyzed, we use the graphical user interface system, that is the GIS media used in HECRAS. And this kind of RAS mapper is mainly used over the HECRAS system. HECRAS is depend over some criteria like single water flow path, single cross-sectional development, water discharge medium, and sometimes the time analysis over the time period. It's mainly use the 1D hydraulic modeling, also some 2D, that is the lateral movement of water, 1D 2D, that is the single directional, and lateral movement of water, sediment transport, temperature and water quality modeling, and also it is used for bridge fire or its effect analysis, that is the bridge development survey. So mainly the HECRAS features is depend on steady unsteady flow simulation. Mainly it's mainly used for the surface water scenario. The steady flow is the laminar flow condition, whereas the unsteady flow generated from the different kind of river channel, and it's mainly used in case of a different hydraulic scenario. The cross-sectional area analysis, so the HECRAS analyzes the different kind of cross-sectional modeling over the hydrological inputs. These are the main inputs of HECRAS. It needs a aerial map, digital elevation model, that is the DAME, we also know it, channel cross-sectional profile, land use data, hydraulic structure, sediment data, water quality data, stream flow data, water surface elevation data, that is the WSL, and finally the discharge data, the seasonal discharge or periodic discharge is necessary for its input. Then it processes as a steady flow water surface profile calculation, unsteady flow simulation, movable boundary sediment transport computation, and finally the water quality. Lastly, its output, the discharge quality, that is the river discharge scenario, differentiate in river discharge, differentiate in river velocity, water surface elevation, cross-sectional and profile, flood animation, flood inundation map, graphs, tables, etc. These are also generated hydraulic data from HECRAS. So HECRAS mainly applied over the floodplain analysis. Previously, I said the bridge fire analysis, bridge design, and real-world example analysis. In this part, the floodplain analysis mainly evolved with the inundation nature of flood analysis over a huge amount of area. This is the main script of HECRAS, which is initializing the HECRAS available, opening a project, and finally, this is the main methodological scenario of HECRAS. That is the chain system of methodological design of HECRAS in that particular area. And finally, the groundwater, the HECRAS part included mainly the surface water, whereas the groundwater mainly included with mode flow introduction. So mod flow is a modular groundwater flow model. Generally, it uses the CAD quality, and in that particular scenario, it discuss the capabilities for simulating groundwater flow, transport, and aquifer characterization, and that is varied from region to region, climate to climate, etc. The mod flow is mainly divided in some part. It invented in 2005. After that, it mainly uses for mod flow FMP, uses for farm process and landscape simulation. Mod flow LGR used for the grid refinement with parent and child model, bidirectional communication. Mod flow SWR, that is the surface water routing and two-dimensional flow. Mod flow CFP, that is the conduit flow process and karst aquifer simulation, mainly the groundwater flow modeling simulation, and mod flow NWT, the Newton formulation of mod flow. And finally, it's related with one water hydrological flow model. So mod flow components are mainly divided in two parts. That is the grid design and conceptual model. There is the grid design and conceptual model. And this kind of model is mainly used in two manners. Explanation of grid design. Generally, in case of a mod flow, we uses two kind of feature. Firstly, we divided the total scenario in gridded definition or gridded data. So this kind of gridded data easily and accurately provided the total function of groundwater flow over the nature, and this is also illustrated the geological and hydrological data are inundated in mud flow simulation. And finally, the stress period, they demonstrate the how mud flow handles transient condition through stress period. So two different conditions is mainly analyzed here. So mainly mud flow application related with the resource assessment of the groundwater resources, and contaminant transport analysis, mainly the water contaminant, that is the groundwater quality, and finally the land use impact, wherever the land use process due to the rapid urbanization process. We also know that where there is a solid framework over the surface, then less amount of water penetrate, and no case of groundwater movement found over that particular area. These are the character and mode flow simulation of a particular land surface, that is the divided in from gravel, coarse sand to clay model. So this kind of gridded simulation is derived from a mountainous to mountainous land formation region. And finally, this kind of model signifies in two parts of study, that is the impacts on water quality. Mainly, the groundwater surface water interaction mainly studied two kind of factors. That is the impacts on water quality. Groundwater surface water interaction mainly nurtured with the nutrient cycling and contaminant transport. Sometimes the surface water is contaminated and it moved towards the ground, and sometimes it's illustrating the impact on agricultural on water quality, especially due to the rapid use of pesticides, herbicides. These are also penetrated in case of a groundwater, and diminishing the water quality of groundwater. So from surface water, it also moved to groundwater, and sometimes we also know the groundwater also perished, also became diminished due to the use of arsenic. Mainly the arsenic problem is also found in the eastern part of our Ganga basin, and this kind of arsenic problem is mainly horrified among the people, and this arsenic situation is mainly diminishes the actual water quality of groundwater, mainly the arsenic pyrite problem. And ecological and in case of ecological importance, that is the in-depth exploration is necessary for wetlands depend on the groundwater surface water interaction. Previously I said that in case of a summertime, when sometimes the water resides of any kind of pond or river, if there is a percolated nature, or the if aquifer move up over the surface, then sometimes the groundwater stress stop, and groundwater flow is happen as a surface water. And showcase of wetland restoration project, mainly this ecological importance is done over surface water and groundwater interaction, especially in wetland restoration project. In case of our Kolkata, there is EKW, we all know that is Kolkata wetland, and this kind of area is also very highly notified due to the groundwater interaction, groundwater surface water interaction, no wetland restoration part. So this significance of studying interaction is mainly divided into two parts. That is the subpermafrost aquifer. In that particular layer, that is the active layer of groundwater is found below the surface water, and from this kind of area, surface water is mainly percolates towards the active layer. So there is a reverse process which also happen in the presence of active layer of this area. So if we use or try to use different kind of bridge, culvert, dam, and their problem over the surface water probability, and so we can use the HECRAS module. So HECRAS module mainly notified how the surface water is flow thoroughly over a high portion of region, and how its effect over the surface water infrastructure like bridge, culvert, etc. And case study over the design and management of reservoir for flood control and water supply, it's also necessary. Actually, HECRAS is used for the policy making purposes. Mainly, if we study a river and if their flood problem is persist there, so we can build various kind of flood control measure like reservoir system, etc. So in that particular case, we develop a prototype in HECRAS and analyzed its applicability over the real surface. So these are the water sector infrastructure system resilience, mainly used for the surface water and groundwater interaction, and mainly used for HECRAS and mud flow in this nature. So from physical and social water system to physical and social water system, these analyzes towards the digital water infrastructure, multi-hazard resiliency from that particular sustainable and resilient system. Finally, the societal impacts is also found. So mainly flood mitigation and managing water resources mainly used in that particular case, flood risk reduction. These two kind of software jointly collaborated in work of flood risk reduction over the floodplain management strategy and implementation of floodplain management strategy over a particular world. And this structure mainly studied through HECRAS and MODFlow. And sustainable water resource management, that is the integration of HECRAS and MODFlow, also study the sustainable water resource management in urban area, where the surface water and groundwater are both found, and these two kind of water is very important to local stakeholders for their livelihood. So these two software mainly HECRAS study the surface portion, and the percolated groundwater portion mainly study through MODFlow. So these nature are mainly studied to this software. They are also integrated part, that is the land use management, water resource management, risk management, and finally they integrated as flood management. All flood management mainly control this fifth kind of material. Land use management, because lands are inundated that time. Water resource management is very essential because sometimes the less amount of water quality which percolated towards the ground. And finally, the risk management, the flood risk association is also necessary to study. So sometimes in case of a case study, we uses the HECRAS and MODFlow in watershed management project, showcasing integrated modeling and comprehensive solution. We can use it. We can use HECRAS and MODFlow in particular urban area with their catchment, and so they are integrated modeling for comprehensive solution purposes, whereas in surface water and groundwater both are studied. And secondly, in urban development project, understanding groundwater surface water interaction in case of a stormwater management system, because in case of urban area, we both know there is a possibility of urban flood due to the water inundation, due to the water logging and water inundation, because the faulty nature of sewage system, and there is a siltation in canal system. So there is an interaction between surface water and groundwater is necessary to study the stormwater management system. Finally, why we learn HECRAS and MODFlow? Because of the three criteria, that is the versatility of hydrological problem solving. Because of there is a various nature of hydrological system which have a versatile type of problems, like some kind, the surface water problem, groundwater problem, and these two are collaborate to solution of this kind of problem. Industry trends and demand, because of the current industry trend in case of a urban area or industry development, groundwater and surface water both have large amount of quantity is required for developing any industry in plateau region or in case of a plain region. So the water quality amount of water is mainly studied through this software. To the career paths and growth prospect over the potential career paths, showcasing diverse opportunity available in water resource, environmental consultancy and research. These both are related with some development of some career opportunities, some growing scholar for their career opportunity to study both HECRAS and MODFlow model in collaborative nature. And this course structure, this both particular HECRAS and MODFlow course structure mainly depend over the comprehensive breakdown of course module like theoretical foundation, hands-on experience, and case studies. In future, we all study in our institute this, and we also done some hands-on experience on that particular purposes, but practical learning or HECRAS and MODFlow is also essential in this area. And if the listeners are enrolled in our classes, then they will reach and get a new opportunity of career, because there is a virgin career system, career faculty is found in HECRAS and MODFlow, except GIS, because these two kind of software, it also uses the GIS interface. So if you have a knowledge of GIS, then you can conclude it easily in to both sectors. So you can enrich the knowledge and become a water resource engineer, so particular development of that kind of area. So these are the total system or total interaction between HECRAS and MODFlow in this section. So if you have a question, kindly ask.